Welcome to Biology My Passion. I am Soumya Harikrishna. Now we are learning the physics chapter, work and energy. We have completed all class 9 biology chapters and first two chapters of chemistry also done. Now let's move on to work and energy, which is the second portion. In this chapter we are talking about work. Along with work, two associated terms are also there, energy and power. They are closely related. Whenever we talk about work, we know to do work we need energy. From where do we get energy? From the food we eat. So anything we do, suppose now I am teaching you, I need a lot of energy. You are watching my video. You may be thinking that you don't want energy, but your body is doing a lot of activities inside, like your life processes, activities to maintain your life are going on. So you need a lot of energy for that also. Respiration needs energy, digestion needs energy, right? Other chemical reactions in your body also need energy. Or you are running or jumping or you are doing sports activities, you need more energy. So all this energy we get from the food that we eat. But are we the ones doing energy? Animals also. They also get energy from the food. But what about the other non-living objects? Fan is working means fan is doing some work, right? Or fan needs energy to do work, or TV needs energy to display the programs, or computer needs energy, mixer needs energy, refrigerator needs energy. From where they are getting energy? From the electric sources. Or we are getting energy in different other forms as well. So any form of energy is required. Over the period of time, human beings have learned to make energy from different natural sources like sun, solar energy, wind energy, thermal energy, which gives a lot of output, or the nuclear energy, large amount of energy can be produced, or hydroelectric energy. We are producing water, the potential energy of water is converted into kinetic energy and we produce electricity out of it. Or fossil fuels like coal and petroleum we use for running our vehicles. All these are different forms of energy that we use. So energy is needed for doing work. So when we talk about work, it has got different dimensions in our day-to-day life or in the scientific aspect. For example, your report card when you get, suppose your mark is less, immediately the comment will be work hard to improve your scores. Or your parents will tell, oh, this is not enough, you have to work hard, you are in 9th standard, study hard, study hard, study hard. Or at the same time, if your scores are already good, you are working hard, then definitely hard working child, or he is working hard, she is working hard, or are happy about your work, right? But in scientific terms, if you say you are not working hard. But don't get disappointed. Don't tell that physics says that I am not doing work, so I am going to stop. No. If you are doing your work, good job, keep it up. So when you are improving your scores, you are struggling hard to improve your scores, you are working hard, means you read the lesson, you make notes out of it, you recollect the points, you revise them, you practice more questions, everything. So this is a lot of work you are doing. But when you define in terms of physics, here we cannot say it as work done. Or another case is pushing a huge rock or a wall. Suppose from morning till evening somebody is pushing a huge rock and the rock is not even moving a bit. The person will get tired, but still we say no work is done. Or I am pushing this wall, okay, but I am applying force, I am getting tired, but I will not say that work is done. Why? Because in physics, work to be done depends on two factors. There should be a force acting there, means we have to apply a force. So only if I apply force can I say work done? No. What else should be there? There should be displacement of the object in which we apply the force in the direction of force. For example, if I push this board from here, I am applying a force and the board is moving in the direction of the force. This is called a work done. So now in this case I have done work. I did not apply much force, but applying a lot of force on the wall, but still the work done is zero here. Why? Because I am applying force, but is there any displacement? No. So work to be done depends upon two factors. One, work is directly proportional to force, and also work is directly proportional to displacement, we can say as yes. So both force and displacement happens only, we call it as work. So now let us different situations and find out whether work is done. First is studying hard. I told no work is done. So because there is no force or no displacement. Pushing a huge rock or wall, force is there but no displacement. Stand with a heavy load on your head. Another situation. You are keeping a load on your head but you are not moving. So you are applying a force on the load and you are getting tired. But are you changing or the displacement happens? No. So here force is there but no displacement. Climb on top of a building, mountain or a tree. You are climbing up a building 10 floors, or you are going up a mountain, or you are going up a tree. All these cases you are doing work, that means you are applying a force and you are reaching the top, your displacement is happening. So of course work is done. Pushing a pebble, a small pebble or a marble, just pushing. Force is applied, it rolls. So again work is done. Pulling a trolley or pushing a trolley, whatever, during shopping we do that. So during that time we are applying force and displacement happens, the trolley is moving, so it has work done. Lift a book through a height. Book has fallen down or this pen has fallen down. I am taking it. So I am applying a force on the pen. At the same time pen displaced from this level to this level. So work is done. Bullock pulling a cart, of course it is pulling and the cart is moving, so it is work done. So here we can say work is directly proportional to force, work is directly proportional to displacement. So we can say the simple formula of work is if you multiply these two, force into the displacement, we get work. Right. Now the work unit we will see. Force unit is Newton, then displacement is meter. So Newton meter, otherwise called joule, is the unit of force. So you can use either Newton meter or joule. Now how will you define joule? See, whenever you want to define 1, the other two parameters should also be 1, only then it will be 1. So 1 joule of work is done on an object when 1 Newton force can displace it through 1 meter in the direction of force applied. Okay, so these are the main things to remember about work. Should be done only when force is applied and in that direction displacement of the object happens. So let's see a question based on the first question from your textbook, exercise 11.1. Here in this case, force is equal to 5 Newton and the displacement given here is 2 meters. We have to find out work. Work is nothing but force into displacement. 5 Newton into 2 meters, it is 10 Newton meter, or we can say 10 joule. So this is the answer. So we just have to multiply force into displacement. It's a direct question, you just have to substitute the value. So here also 56 Newton meter or 56 joule we can say. Now when the potter is lifting a body, whenever you are lifting something, you are working against the force of gravity. So whenever there is work done against gravity, the answer can be found out or work done can be found out by multiplying the weight of the object into the vertical distance in which it is lifted up or traveling. So it is 15 kg luggage is lifted. So here we can say the weight of the body or the weight is equal to m into g. M is 50, g is acceleration due to gravity. If it is not specified, you can take g as 10. Actual value is 9.8, but you can take it as 10. And work done is equal to weight into vertical distance. Vertical distance is the height in which it is lifted up. So actually the formula becomes mgh. Whenever there is a work against the gravitational force, we have to multiply with the weight, that is mg, into the vertical distance or the height. So in this case it becomes 15 into 10 into 1.5 meters. So 10 into 1.5 will become 15, 15 into 15, 225 Newton meter or 225 joules is the answer. We know that work done is force into displacement, but it can vary in different situations. Work done can be positive, work done can be negative, or work done can be 0 also. See, in which case it is positive? When we are applying a force and the displacement is also in the same direction, force applied and displacement are in the same direction, then we call it as a positive force. For example, when I am pushing this board, okay, I am applying force on that direction and my board is also moving in that direction, then I can call it as a positive force. Or I push from this side. Now my force is to this direction, the movement of the board is also in this direction, then it is a positive force. Or you are pulling a body, means an object, maybe a trolley. Okay, suppose you are pushing a trolley, right? You are applying force in that direction, that is also moving in that direction. Or you are pushing a car, okay, or you are pulling something, it is coming towards you. So your force is in that direction, displacement also in that direction, then in that case we call the force as positive. Suppose an object is freely falling under the force of gravity. So when it is falling freely and without any other force, the gravity is pulling it, right? So what is the work done by gravity here? Positive, because gravity is towards the ground and also the displacement is also towards the ground. So work done by gravity on a freely falling object is positive. Or at the same time, or a spring is being stretched, in that also work done is positive. Now there can be negative force, that means we are applying force in one direction and the displacement in the opposite direction. A stone is thrown up, but it is against the force of gravity. So force of gravity is in the opposite direction of the movement of the stone. So we can say it as a negative work done by the gravity. Or there is a surface, very hard surface like this. On this an object is moving. So when the object is moving, the frictional force or the rough surface is acting a force that is called a frictional force, that is opposite to the direction of the movement of the object. So that we can call it as negative work. And a vehicle is moving forward and we are applying a brake. The force applied by the brake is negative. So because it is against the displacement. So these are all examples of negative work. Now coming to zero work. Sometimes the work done can be zero. When the work done and that is the force of direction of force and displacement are, then it is work done is called a zero. Imagine a porter is there, he is carrying a load. Okay, so he is applying a force on the load to balance it equal to the weight of the load. So force is in this upward direction, but he is walking in this direction, so displacement is in this direction. So here the angle between the force applied and the displacement is 90 degrees. So in that case, is it a positive, negative or zero? It is zero. The same way, if I am tying a stone to a thread and I am just rotating it. So at any point of time, the force acting on that and the displacement, if you see the tangent, then it is 90 degree. So in that case also we can say work done is zero. Okay, so when you go to higher class, you will understand that work is of F into S, but F cos theta. So there the angle of theta, that means depending on that 0, 90 and all, the values cos 90, it is 0. So the value is changing accordingly. Hope you understood all the concepts very well. If so, please share with all your friends and subscribe to my channel Biology My Passion. Thank you for watching.